EndoMetric is a company that uses image analysis to develop products for endoscopy to measure events and improve outcome. Where possible, events are detected during endoscopy and outcome is improved by real-time feedback. All measurements are completely automated and saved in relation to the point in time that the event occurred. Events that can be measured include taking of pictures, detection of polyps, detection of instruments such as biopsy and polypectomy. Quality parameters that can be measured include withdrawal time, amount of stool, effort to inspect the lateral wall and folds of the colon. Overlay technology similar to technology used by the NFL during football games on TV shows feedback on the existing endoscopy monitor. Next, a video of a colonoscopy is shown. The start of the colonoscopy and thus the video is automatically detected. As soon as EndoMetric software detects that an endoscope enters a patient, the on-screen message EMIS Insight appears as shown in the right lower corner. EMIS stands for Endoscopic Multimedia Information System. When the endoscope is outside the patient, the message displayed in the right lower corner is simply EMIS on. That way, the user knows that EMIS is available. There is no feedback during insertion other than EMIS Insight to indicate that the system is available. When the withdrawal phase starts, EMIS is activated via a number pad, the only non-automated step in EMIS. In the next video clips, effort to inspect the lateral wall and folds, or spiral score, will be shown as example of an EMIS measurement. First, this is shown in a model colon, where a green X marks the center of the distal colon. First, the procedure is started. Next, the feedback is started. The total circumferential score is shown in the right upper quadrant. First, we will inspect the right upper quadrant, as marked by the green triangle, then the right lower quadrant, followed by the left lower quadrant, then the left upper quadrant, and eventually the next circumferential withdrawal is completed by inspecting the right upper quadrant. Next, we show activation of EMIS during an actual colonoscopy. The green X is not shown. We are in the cecum and a picture of the appendix is taken. Next, EMIS will be activated, shown by the spiral score being 0 in the right upper corner. EMIS will now start to provide real-time feedback. EMIS works both using regular white light as well as using NBI, VICE, or iScan. Watch closely when the right lower quadrant is inspected and next when the left upper corner is inspected, as you will see the green triangle marking this event. Now we will speed up the video so you can see the scores slowly going up. We're now in the terminal ileum and no score is added. We're back in the cecum and now are washing and slowly withdrawing the scope while carefully inspecting the colon in a circumferential fashion. This results in a gradual increase of the spiral score, again as shown in the right upper quadrant. EMIS evaluates only clear frames. No marking is happening during this suctioning. At the end of the procedure, EMIS can provide a summary report. The user has at least two options. The first one is by pushing a key on the number pad. The second one is an automated appearance 2 minutes after completion of the procedure. This to allow reinsertion of the endoscope during polyp retrieval. As for all features of EndoMetric, the report can be customized. Here we show a sample report that includes an overall quality score, the horizontal colored bar, separate scores for colonic preparation by the patient, a cleaning score reflecting endoscopist effort, and the spiral score explained earlier in this video. The end of insertion image is shown, here the appendix, as is a time axis where the end of insertion and end of procedure mark the beginning and end of the withdrawal phase. The spiral score is shown as a graph. As you can see, there are 7 small graphs in series, each graph consisting of 4 quadrants. Finally, insertion and withdrawal times are shown. More importantly, the clear withdrawal time, that is the time looking at clear frames, is shown as well. Are there potential benefits of combining EndoMetric technology with electronic medical records? We believe there are, and in the next slides we'll give 5 examples. First, EndoMetric can provide automated report prefill. This is to decrease clicks or mouse miles. For example, for colonic preparation, abbreviated as stool, EndoMetric can provide measures of stool pixels, estimates of ECG or Boston Bowel Preparation Scale, and cleaning activity. Maximum insertion can be estimated from recognition of the appendix or terminal ileum. Similarly, there are measures for time points, inspection activity, findings, and therapy. Many of these could be used to prefill much of a regular endoscopy report. Under best of circumstances, the endoscopist confirms the entries with very few clicks. Second, EndoMetric can make sure your images are always sharp, avoiding the need to take multiple images. As EMIS has the entire procedure, the best image surrounding the image taken can be automatically selected. For instance, within a time span of plus or minus 2 seconds from the image, or within 240 images. Third, EndoMetric can provide automated image annotation during endoscopy. Most endoscopists take images for specific reasons. For instance, to mark anatomic locations such as the cecum, appendix, or terminal ileum, or to mark findings such as polyps, diverticula, hemorrhoids, melanosis, colitis, and ulcers. EndoMetric already has developed algorithms that can automatically detect many of these features and create the likely associated annotations for many images taken by the endoscopist, and have these ready for review at completion of endoscopy. EndoMetric can go back in time for video clips and create a clip a week after the procedure was completed. EndoMetric automatically creates a digitized video file of the entire endoscopy that is kept for a user-defined time, for instance 5 to 25 working days. If the endoscopist forgot to create a video clip of a key lesion or procedure, now the ability exists to go back in time. For instance, if an image exists, EndoMetric can simply create a video clip from X seconds before the image to Y seconds after the image. As already shown earlier, EndoMetric can create automated quality reports for each endoscopy. Quality features include stool score and cleaning activity, withdrawal time and clear frame withdrawal time, and spiral score, which shows statistically significant correlation with adenoma detection rate. Most importantly, all data can be automatically uploaded to an electronic medical record. Now let's look into the future. EndoMetric is working on a number of projects that may interest endoscopists. Here a list of examples. Because the EMIS technology gives complete control of every pixel, EndoMetric can create very dense video compression with virtually no loss of information. Compression may simply be a clear frame along a specific colon axis distance, resulting in 100 to 1000-fold compression. Given such compression, all procedures ever performed in the lifetime of a single endoscopist could fit on a single hard disk. Automated polyp detection may increase adenoma detection rate. A map of the mucosa inspected may help endoscopists go back to re-examine specific parts of the colon. Scoring of inflammatory bowel disease for degree of inflammation and location is being investigated. Completeness of polypectomy likely can be assessed using novel algorithms. And lastly, EndoMetric is already working on endoscope guidance, that is directing the endoscope to the cecum, and once that is achieved, therapeutic targeting and therapeutic guidance, that is support to remove lesions, will be pursued. Next, two examples of EndoMetric projects: polyp detection and mucosal inspection map with 3D fly-through. First, polyp detection. Here, EMIS is scanning the image in real time for polyps. Once a polyp is found, EMIS marks the outline of the polyp with red dots and places a green circle near the polyp to facilitate recognition. EMIS can track each and every fold as shapes, as shown here, and as light reflection. The information from 2D images is used to create a 3D map. The white cylinder represents the tip of the endoscope flying through the colon along its central axis, shown in red. As you can see from the mucosal inspection percentage shown at the top, during fly-through without any tip deflection of a relatively straight colon segment with shallow haarstray, about 93% of the mucosa is inspected. This estimate from EndoMetric fly-through measurements agrees well with estimated percentages from experts endoscopists. Of course, we can fly through the colon in forward as well as backward direction. That concludes an overview of EndoMetric technologies. We thank you for your interest and hope that the examples shown have given you some idea of our abilities.